All right, in our last lesson, we learned how to use SOH to find missing sides of triangles, and today we're going to look at some word problems where you do the same thing. So first of all, the key is reading the problem and finding the right triangle. So what you want to do, you always want to start by drawing a picture. Some questions might already have the picture there. That's great. That's like an extra hint for you, sort of. But if not, draw a picture of what's being described. Now from there, you want to find the right angle, because the right angle helps you find the right triangle. So you're looking for that 90-degree angle. Now here's some hints of things in word problems that make right angles. Number one would be directions. If you're talking about north, south, east, and west, that's usually going to be your right angle. Number two is altitude or height. Anytime a question says something is so many feet tall, or an airplane is a mile in the air, or something like that, anytime it's describing height or altitude, that makes a right angle with the ground. Now the last one is anything on the ground. And this one maybe isn't all that realistic. Like sometimes a tree might be growing at a little angle, or a ground might be slanted. In a word problem, unless we're told otherwise, we always assume that the ground is perfectly flat, and that everything is perfectly vertical. The trees are perfectly straight up. They make a right angle with the ground. Flagpole, perfectly straight. A person standing perfectly straight. So anything on the ground, unless it says in the question that the ground is like a 20-degree slope or something like that, unless it very specifically says that, we always assume the ground is flat and everything is perfectly vertical, and that's your right angle. So once you draw the right angle, or once you draw the right triangle, label everything you know. If it says this person is 6 feet tall, label them 6 feet. If it says this tree is 20 feet tall, label it. If it says a person is standing 50 feet away from a tree, label that distance between the person and the tree 50 feet. Just label everything that's told in the question. And then go back to the question and look at what you're being asked to find. If it says, how tall is the person? Call that X. If it says, how tall is the flagpole? Call that X. If it says, how far away from the building is the person standing? Put an X on the ground between the person and the building. Whatever you're being asked to find, call that X. Now, if you've done each step correctly, if you drew your triangle, you labeled your information, and you called what you were trying to find X, then it's basically not a word problem anymore. It just becomes a solve for X triangle, exactly like what we did in the last lesson. So let's do one example together. It says, the angle up from a ship at sea to a 100-foot tall lighthouse is 7 degrees. How far is the ship from the lighthouse? So let's start with a picture. So we're talking about a ship, so let's say this is the water here, and over here somewhere is a lighthouse. This is a lighthouse. It's beaming a light out like this. And over here somewhere is your ship. Now it says the angle up from the ship at sea to the lighthouse, like that. That's 7 degrees. So my picture's a little bit messy. I don't have very straight lines, but you can see the triangle there. I'll outline it in red. One triangle is the ground, or one side is the ground or the water. One is the light tower, and one is that line connecting the boat to the top of the light tower. Now the right angle is here, because remember, one of the things I said is we always assume the ground is flat, and we always assume everything, like a light tower, is perfectly vertical. So that's your right angle. So what I have right now is a right triangle with a 7-degree angle in it. Now the other piece of information that was given in the question is that the lighthouse is 100 feet tall. That would be right here. The last thing I need is an X. And the question asked me, how far is the ship from the lighthouse? I'm going to assume they mean the bottom of the lighthouse. They mean like how far across the water is it until the boat gets to the lighthouse. So I'm going to put the X right here. Now, forget about the picture. Forget about, the lighthouse and everything else. It's just a triangle question. It's a right triangle where I gave you one angle, 7 degrees. I gave you one side, 100, and I asked you to find another side. We can do that with SOH. So let's now label the sides, opposite, adjacent, and hypotenuse. Since the bottom of the lighthouse is the right angle, this would be hypotenuse over here. Since I'm using the 7-degree angle in the question, that makes 100 opposite, and that would make x adjacent. So what I'm using for my question is O, the 100, and A, the x. From SOH, let me write it up here. We always come back to SOH. What I'm using is O and A. That makes this a tangent question. So I'm going to set up the problem for tangent. Now remember what we said in the last day of notes. Once you choose your trig function, sine, cosine, or tangent, the thing that always comes after is the angle. So that would be tangent of 7 degrees. And it equals, you can just look back up here at SOH again, it equals opposite, 100, over adjacent, which is x. Now remember, we decided for our first step, we're going to go ahead and grab a calculator and figure out what tangent of 7 is. So let's do that. So I do tangent of 7, and it's going to be about 0.122. Now also remember from our last day of notes, the difference in this question is whether the x is on top or on bottom. When x is on top, it's actually a little easier. You can finish the question in one step. But on ones like this where x is on the bottom, the best way to do it is probably to put this over 1 and cross multiply. So let's do that. I'm going to do 0.122 times x, which would be 0.122x, equals 100 times 1, which is 100. And then, let's get some space here. We would finish up by dividing by 0.122 to cancel that out. And we'll use our calculator again. If you do 100 divided by 0.122, you should get your answer. And x ends up being about 819.6 feet. And that's how that boat would know how far they are. Lighthouses are usually put on the edge of land, so a boat will see it and not run into the land. So now, by knowing how tall that lighthouse is, and by measuring the angle up to it, the boat can know that they're about pretty close to 820 feet away from the edge of land, basically. But the idea is, I did exactly what I described to you guys. I read the question, I drew a picture, I labeled information and my x, and then it wasn't even a word problem anymore. I basically just solved the triangle using SOH, and it ended up being tangent.